Okay guys, so we're getting into logarithm functions, alright? So here we have the exponential function, right? Exponent function, and we're gonna switch that to logarithm function because they are inversely related. Okay, so you're gonna see how exactly that's gonna work out. So 2 to the power 3 equals to 8, and what's the base here? The base is gonna be here, that's the 2. And what's our x? Right, that's our first variable. It's going to be 3, and that equals to our y, which is our result right here. That's our 8, right? But that is inversely related to logarithm. So 2 it was our base, so you write it right beside the log sign over here, and you're gonna have 8 as the result. Okay, so it's focusing on the exponent. So we are trying to get the exponent, which is our new y, right? So you can see how exactly it's switched because the result comes to our x position, and our new result is our old x, right? Old x. And 2 to the power 3 equals to 8. That is exactly saying inversely related to logarithm 2 and of 8, right? And equals to 3. Okay, base 2 of 8 equals to 3. So we're gonna try to get to 3, and we switch 3 with 8. So you can see 8 becomes over here. That becomes our x, and our base is just basically, these two bases are basically like coefficient, or you can think of it as, think of it as coefficient. All right, and okay, so let's do another one. 4 to the power of 2 equals to 16. So how are you gonna rewrite that? So where is our base? So the first thing is to get the base, right? 4 log to the power base 4, and the result was our y, and it becomes our x. So we put it right here, and that equals 2. That makes sense. 4 to the power 2 equals to 16. 4 to the power of something, we don't know. We haven't calculated that, but to the power of something, that equals to 16. Okay, so that's our variable. We don't know. 4 to the power of something, y something, but we don't know, and that equals to 16. So later on, if you plug this into our calculator, that goes to 2. So you can see that it's exactly the opposite, or inverse, right? And logarithm of 3 to the power of something, right, our y, equals to 81. So that square should be, fill out the square, it's going to be 4. Right, 3 to the power 4 equals to 81. How do you figure it out without a calculator? If the number is not too crazy, you can figure out, but just by multiply it again and again until, right, like you did with the exponent. So you just 3 times 3 times 3 times 3 until you get to 81. That's how you figure it out, right? And so we have another Euler's number, right? That's the sign. We're gonna introduce it later, but that is okay. If you say that's okay. So this correction, this is like exponent. I meant exponent. Okay, that's not, try not to. We were gonna talk about Euler's number, but for now this is exponent. That is exponential, inversely related to logarithm. So first thing first, we're gonna find the base, and then we're gonna find the result, which is the y in our exponential expression, and then we're gonna find lastly the exponent itself, right? That's how you do the logarithm form. Okay, so we're gonna reverse that. We're gonna try to figure out logarithm, and we're gonna try to inverse that back to exponential form. So you're gonna have a logarithm form here. Log, that's the base, that's the result, and that's your exponent. And you're gonna rewrite it like this, right? The base and the exponent of course, it's going to be our result, which is a big number, supposedly. But you could have negative, so you're going to have a fraction going under the 1. And then try to figure out 3 to the power of something equals to 1 over 9. Okay, 1 over 9, you know, is fraction, so it's going to be negative. So inverse that. Negative something equals to 9. Negative 2, right? Negative 2 becomes 3 to the power of something equals to this number here. So it's going to be 2, but when you switch it up, it's going to be negative 2 because 3 to the power negative equals to 1/3, right? So 3 to the power of negative 2 equals to 3 to the 1 over 3 to the power of 2. Okay. So let's try this. This is our Euler's number, okay? Euler's number, if you plug it into our calculator here, Euler's number equals to 2.718. Okay, that's introduced by just 1 plus something, the rate, right? And 1 over that. And you try to exponent that, or take the exponent of that number, this number here, right? And then you figure out the exponent. It's just like pi, right? We can prove that maybe later on. We're gonna go into detail about the Euler's number, but for now, let's remember it as a pi, another kind of pi, right? 2.718. Okay, and so when you talk about Euler's number, e to the power of something equals to another kind of result, right? If you wanted to plug it in yourself, Euler's number, and then I'm gonna to the power of 2, let's say, that's gonna be 7.389, okay? 7.389, so e to the power of, what was it, 2, right? That's gonna be 7.389. Alright, that's good to know, but how do I change this to logarithm? Because we're talking about the logarithm function, right? So that equals to log, natural log, right? Because when you talk about the Euler's number, we're gonna use, just like when we have different set of rules for a pi, right? So we're gonna switch the log to natural log specifically for the Euler's number. Okay, so when you say natural log, you automatically assume your base is gonna be Euler's number, and your 7.389 is gonna be here, right? 7.389. But we try to figure out, oh, what's the exponent of Euler something, right, to the power of something equals to 7.389. That's what we were trying to figure out with this equation, right, with this expression. So that equals to, we talked about this, 2, right? Okay, 2. So that's Euler's number in an essence. But how about log when you don't write the base? And majority of the time when you have your calculator, when you take out your calculator, there's no options for switching the base. Okay, so you just say log, right? But this automatically assume that your base is gonna be 10. So we're not gonna write 10 anymore for our base, because okay, if you write like this, 10 base is 10, 100, that equals to 2, right? It's because 10 to the power of 2 equals to 100. Okay, see how that goes? Goes from here to here and that to here. Alright, so we're not gonna write that anymore. After that, we're gonna just say log 100 equals to 2. Okay? Alright, let's figure out another question here. I believe it's in, okay, evaluating.
much as I did.
Okay, right here. So log to the power of
2 of 8.
Right.
Is equal to
So
1/8.
It was saying when you write this, log to the base is 2, right? Log base 2, 1/8 of 8 equals to 3. But when you reverse that, it's gonna be the root, right? The root of that, right? The root of that. So it's gonna be 1/3. The 1/3 part is gonna be, when you write like this, you just do the same thing. It's nothing too advanced about it. You just have to figure out how you're gonna get to the number. All right, so let's copy some of these questions here. Log A2, and we're gonna try to figure out what that's 1/3. And log 2, base 2, 1/8. We're gonna try to figure that one out too. All right, so okay, log 2, 1/8. So what is our answer here? Actually, I'm not gonna write x. I'm gonna write this for now so it doesn't confuse you. Exponent, right? Okay, it's 2 to the power of something, exponent, equals to 1/8. So immediately you're gonna see, oh, it's gonna be negative, right? Negative, because it's in our fraction, right? It's in our fraction. We have an exponential expression here. Anything that is negative, right? -1, -2, it's gonna be fractions because it's underneath 1 and between 0 and 1, right? So it's gonna be fractions. Alright, so what we trying to do here is to figure it out if 2 to the power of something, right? And we're gonna add a negative sign at the end. Okay, 2 to the power of something, that equals 1/8. Right, 2 to the power of -3. -3, because 2 to the power of 3, 1 over that, right? 1 over that is going to be negative, so it's going to be 1/8, exactly what we want. Okay, so our answer is going to be -3. The log form of this is going to be -3. Okay, right here, or well, it says x here, but that's just a variable that it's assuming it's x, but when you come to think of it, it's going to be like y. Alright, y equals to -3. And so, well, how about this one right here? Log 8 to the power of 2 equals to something. We haven't calculated that, but we're going to try to figure that one out too. Log 8, is it 2?
Really?
Okay, 2. Okay, so we try to figure this one out. Alright, testing. Okay, we're fine. So 8 to the power of something equals 2. That one is tricky, right? But when you think of it, it's the square root of that, right? It's the square root of that number. What do I mean by that? Square root of something, 8 square root of something, because I'm trying to get rid of the exponent right here. That equals to 2. This is essentially what the question is asking you. Log 8, base 8, 2 is asking you square root of 8. No, not square root. We don't know the root of the number of 8 yet, but we know that equals to 2. Can you figure this one out? Something 2 times how many times, we don't know, equals to 8, right? That's essentially what the root of the sum number is asking you, right? So 2, how many times does it have the times that to get to 8? So the answer would be 3. Okay, the answer would be 3, but we take a square root of that. So how do we place that? How do we place this whole thing to our exponential form? Right? How do we express that? How do we express a root of something? Of course, it's gonna be 1/3, right? 1/3. 8 to the power of 1/3. That really actually means you take the third root of 8, right? Okay, so the answer is gonna be 1/3.
Mix
You
it up.
see the answer
What
here?
would be full of 2 right over here? We have to just raise.
So let's do the other one. Log 8 to the power of something that equals to 1/2. 8 to the power of something equals to 1/2. So we need a negative number, right? Because that's a fraction. So we know we need a negative number. But how do I get to 2? Right? How do I get to 2? How do I get to 2? Because we know 8 to the power of 1/3, that it gives us 2. That gives us 2. So how do I use that relationship and get to 2? Okay? This is what the question was asking us, right? Log 2 to the power of 1/8. Oh, here, sorry. Log base 8, 1/2. That equals to what number? What can you do to get to 2? Okay, so I'm gonna try to get to 2 first. I'm trying to get to 2 first. So how do I do that? I'm gonna figure out the negative later, right? I'm gonna try to figure out the negative later, or we can add on the negative later. But I'm trying to get to 2, just 2. 8 root of 3, right? Right? Third root of 8 is gonna be 2, right? Because 2 times 2 times 2 equals to 8. So that's gonna be 2. Okay? Something times something times something. They have to be the same narrow squares. That equals to 8. So our answer is gonna be 2. Right? Perfect. So we know this is our answer. The third root of our number 8, right? So this is our third root. If you put it into exponential form, remember we're trying to get to that number. The exponent is our ultimate result. But we have 1/2 here. That only gets me to 2. So we're trying to get that down to the denominator. So over that, right? So 1 over that, so I'm gonna add a negative. So that my number is gonna be 1/2. Okay?
And we already know the cube root of 8, or 8 to the 1/3 power, is equal to 2.
Right, you see the answer here? Negative 1/3. Okay? So the answer for this is gonna be negative 1/3. Okay, so let's move on to the relationship between exponential and logarithms. They are inversely related.
Rewrite the following.
You see here, 100 equals to 10 to the power of 2, duh, right? But we're gonna take the logarithm. So how do I do that? So log base 10, right? And our answer is 100, and that equals to 2. So you can see here, right? Log base 10 102. Alright? So the other one, this is the logarithm form. We try to get that into exponential form. So phi to the power of something, which is -3. Phi to the power of -3 equals to 1 over, right? Negative meaning over 125, because phi to the power of 3, right? Phi to third power is 125, but it's going to be revert to the denominator because we take the negative sign, right? Okay, so let's move on. The relationship is in fact negatively,
The 3 points plotted below are
inversely related. So if I say it's inversely related, how about this, right? We're gonna try to add a log base here. Try to get the log base is gonna be 2, and our new x is gonna be inside, right? So that equals to y, that equals to y. So see, our y becomes x and our x becomes y. It was 0, 1. That's our first identifiable coordinates for our exponential function, right? But when you inversely relate it to that, our coordinates becomes 1, 0, because it was 0, 1, and we inverse that, it's going to be 1, 0, right? X becomes y, y becomes x. Okay, so let's take another look at 1, 2, right? Or before it was 2, it was 0, no, before it was 1, 2, and then we have 2, 1 here and here, right? 1, 2, and 2, 1. So exactly folded on y equals to x, right? Let's see here, y equals to x. Okay, the green line is y equals to x. It folded on the green line. When you fold that number, right? When you fold that, it overlaps. Okay? So that's gonna be it. And what else? So when you see this, you know this is what kind of exponential function here is 4, right? 4 to the power of x equals to y. That's our function here, because anything to the power of 0 equals to 1. All right, so we start from 1, that's all right, and then 4, and then 16, because 4 to the power of 2 is 16. But what's that gonna look for our logarithm? So we just fold that, right? Because it's inversely related, so we just fold that. Here you can use the table as well. We fold that, so 1, 0, 1 becomes 1, 0. 1, 4 becomes 4, 1. 2, 16 becomes 16, 2, right? 16, 2 is right here. So you'll form another logarithm which goes from here to there, right? Here to there. And of course our y becomes having negatives because it was the x before. Do you know what I mean? Right? It was the x before. Now you inverse that. Of course, your y has to have negatives number, because before our x has, our domain has, in our exponential form, it does have negative numbers. Okay, that's the relationship. Let's move on to tables. Okay,
column right over here.
Check out the table. Hey guys, so we are still on tables. Here we have two tables. One is the exponential form, and the other one is logarithm form. Alright, so you're gonna plug in the x over here. So b to the power of 1.585 equals to 3. So we don't know b yet, but we know that b to the power of 1.585 equals to 3, alright? And we know that b to the power of 2.322 equals to 5. We don't know the base yet, okay? The base for the exponent. But also looking over here, the question might specify that these two are inversely related. So you can see that the logarithm form, you have the same base, the same b over here, right? Same as the x, right? So your x before becomes your new y, all right? So log base, we don't know the base, of a equals to 0, right? Log base of 2 equals to 1. Log base of 2c equals to 1.55. Log base of 10d equals to 2.322. Alright, so let's figure out a first. Alright, we do it in this order, a, b, c, d. And a, so a is going to be b to the power of 0, right? B to the power of 0 equals to y. Your y plug into here, your a plug into where your y is over here. So b to the power of 0 equals to a, okay? Let's use our whiteboard here just to clarify things. Okay, b to the power of 0 equals to a, right? So anything to the power of 0 equals to just 1, right? 3 to the power of 0 equals to 1. So we know that a equals to 1, okay? So now let's move on to the second one. Log base, right? And you got a 2 right here. Base to the power of 1 equals to 2. So what is our base? Of course our base is going to be itself, so it's going to be 2. Okay, so you look over here, we can now plug in the exponential form and all things are clear, right? What do we have? We have two kinds of form. One kind is exponential and the other one is logarithm with a base of 2, right? Here we have a y, but you know this is the x for the logarithm, right? It was the y for the exponent, but here it got transferred to here. But in this scenario, it just referred to different variables. You don't have to look into x and y that much, okay? And that just representing our result. And so we move on to c. So how do we find out the c over here? We have b to the power 1.585 equals to 2c, okay? So let's go back to here, to our whiteboard. 2 to the power of 1.585 equals to 2c, okay? So of course you can say, oh, let me just plug this into our calculator, but you have a graph, you have a table right here, right? b2 to the power of 1.585 equals to 3. So you don't have to do anything. You know for a fact that this equals to 3, right? This equals to 3. So 2c equals to 3, c equals to 3 over 2, right? You got it, okay? And then same method applied to d as well, right? You're gonna check out your table right here. So it's gonna be b to the power of 2.16. We have it right here, 2.322, right? You have to match the numbers, match the exact numbers to get the numbers down here, okay? So b to the power of 2.322 equals to 5. So you know that the opposite, right? This is going down and this is going up. 10d equals to 5, okay? 10d equals to 5. What is our d? d equals to 1/2, okay? So that concludes our answers here. So you can see a equals to 1, b equals to 2, 1.5, and 10d, right? Our base is 2, okay? So that is our answer here. So hope you have a great day, and thanks for watching.